Okay, so we're first of all going to solve a quadratic by the most appropriate method. The first method is by taking square roots. So what, if you want to notice here, x squared equals p, where p is some number, we can just solve by taking a square root. Because what undoes a square? A square root. So we would square root both sides. So then we would get x is equal to plus and minus the square root of p. So just a reminder, all quadratics should have two solutions since they're degree 2. So when solving and we take a square root, we can't forget to put a plus or minus. So first of all, you have to isolate the square. Get it all by itself. So first we'd add 9, wouldn't we? Yes. So p squared equals 9. Then we'll take the square root of both sides. So p is equal to plus and minus 3. There's our two solutions. Easy, right? So right here, take the square root. Square root. Now look, why is this in this unit? Because we know how to break down that. We can't forget plus and minus, and then that breaks down into 8 times 6. 2 times 2 times 2, and then 6 is 2 times 3. So wouldn't that be p is equal to plus and minus 4 root 3? Right, everybody? Okay, awesome. So let's keep going with this. Before we take a square root, what do we need to do here? Get it by itself. Yeah, get it by itself by dividing by 3. So then we'd have b squared equals 25. So then we would have b is equal to what? Plus or minus 5. Right here, x is equal to plus or minus 9. Good. Awesome. Okay, let's look at this one. So the first thing we do is subtract 14. So then we have y squared equals negative 12. So then when we square root negative 12, we break it down into 2 times 3, wouldn't we? So, yep, so y is equal to plus and minus 2i root 3. Easy. Yeah, because that's what we learned last time, with i's. Okay, now this is no different. Look, now there is something more. X minus 2 is all trapped in the square, but we're still able to solve by taking square roots. So understand, in the past, we were not able to just square root it because this had like an x on it. We can't square root an x, you know? But we're at 25 is just a constant. We isolate the square. That's the square. We'll square root both sides. Root cancels out with power. Here's the important thing. X minus 2 is equal to, you got to put the plus and minus wherever you took the square root. So it's plus and minus 5. Then from there, split it up. X minus 2 equals 5. X minus 2 equals negative 5. So then add 2. X equals 7. Add 2. Add 2. X equals negative 3. Notice, these are not opposites. So we got to put the plus and minus in the correct spot. And that's where when you took the square root. So let's do this one. First thing we would do is subtract 24. Y plus 5 squared equals negative 24. Then we would square root both sides, not forgetting that we need to take, when we take the square root, we need a plus or minus. So we have y plus 5 is equal to plus and minus, and then let's simplify this. Isn't this 6 times 4? 2 and 2, 3 and 2. So wouldn't that be plus and minus 2i root 2i root 6. Now we have this. Y plus 5 equals 2i root 6. And we also have y plus 5 equals negative 2i root 6. So next step is to get y alone. So we'll subtract 5. Now just a question for you. We learned last time complex numbers have a plus bi form. So shouldn't we write negative 5 first? Negative 5 plus 2i root 6. And then we'll subtract 5. So y is equal to negative 5 minus 2i root 6. Two solutions. So it's just combining a lot of stuff we've learned. Simplifying radicals, imaginaries, and whatnot. Okay, this is where you need to take notes. We did not learn this in Sec 3 because it was not necessary. I never teach solving. So really, when I say solve the quadratic, we see if it factors. If it doesn't factor, we do quadratic formula, right? If you remember, that's usually the steps we take. So I never teach completing the square. This is a method we learned in Sec 2. And everybody in Sec 2 thinks it's so hard. You're going to laugh at yourself when you see it now, or your brain is so much more developed that you thought it was hard back then. So the reason we're learning it this time is because on the test, it will specifically say, solve by completing the square, and you'll have no choice. So it's actually, people actually really like completing the square. Once they've learned it at a more advanced level, people hate it in Sec 2, but then once you see it now, you might love it. It's pretty easy, actually. So first of all, what we do is isolate the variables to one side of the equation, and then get the constant to the other side of the equation. So on my first step here, I'm going to add 8 over. So everything with a variable needs to be on the left. So that would be x squared plus 2x, and then we we have now is equal to, I added 8, is equal to 8. So everything with a variable on the left and our constant on the right. This is just the steps we take to complete the square. That's our first step. Questions on step 1? Then step 2 is complete the square. So I have a square. This is the value that completes the quote squared. So what we do is we take b divided by 2 and then we square it. B divided by 2 squared. Well, where does b come from? Quadratics have the form ax squared plus bx plus c. So b is what's in front of x. So what would my b value be here? 2, wouldn't it? Right? So that's what we do. You just have to, this is something you just have to have memorized. That's what completes the square. B divided by 2 squared. So we do b divided by 2. So 2 divided by 2 squared. I show my work. There's a reason. That would be 2 divided by 2 is 1. So we have 1 squared, which is 1, right? That's the value that completes the square. So what we're going to do is we're going to add that to both sides of the equation. So we're not changing it because we're doing it to both sides of the equation. Remember, if we do something to both sides of the equation, it's okay. So what I'm going to do is I'm going to add 1 to both sides of the equation. We're choosing to manipulate it in a smart way. You'll see why. So now look, over here on the left, rewrite what we have. We have x squared plus 2x plus 1, and that's equal to 9, right? 8 plus 1, 9? So now what's the point of that? Well, guess what's going to happen now? This will always happen. The left side now this is standard form. The factored form is going to be something times itself again. So it's going to become something squared. So let's factor this bad boy. Standard form and factored form are equal, so let's factor it. What multiplies to be 1 and adds up to be 2? 1 and 1, right? So that side factors to be x plus 1 times x plus 1, doesn't it? Yeah. I'm going to write it as x plus 1 squared, because that's the same thing. So we have not changed the left side. I'm going to just scroll up, and then we still have equals 9 there. I'm just scrolling up here. So we just factored it. Instead of having it in standard form, we have it in factored form. X plus 1 squared, and that's now equal to 9. Well, why was that useful to solve? Because now we can just square root it. Yeah. Oh my goodness. Yeah. So now we just solve. So we'd say, okay. Now that'll always happen, guys. It'll always factor to be something times itself. This and this will be the same.
So the most important step is making sure that once you do the divided by 2 squared, you make sure that you add it to both sides?
Right. That's the key, is adding it to both sides, yes. So now just solve for x. So we'd square root both sides. So we have x plus 1 equals plus and minus the square root of 9. So we have x plus 1 equals plus and minus 3. So we have x plus 1 equals 3, and we have x plus 1 equals negative 3. So our two solutions are x equals 2. Subtract 1, we get a 2. Subtract 1, we get a negative 4, everyone. There's our two solutions. So we solve by completing the square. It's just a manipulation technique to rewrite the same problem in a different way. I want to show a fun fact for you. You really want to know this fun fact. I'm promising you that. We know how to factor, so without this fun fact, we'd be okay, but there are times when it's going to be really nice to have this fun fact. So right here I said factor, and you did what multiplies to be a times c and adds up to be b. That works. Now, fun fact, so we did b divided by 2, which we simplified, and then we squared it, and we got 1. That's the part we add to both sides. Now, fun fact, it will always factor to be, before you actually square it, what's inside your parentheses, it'll always factor to be that twice. Do you see how that's positive 1? It factored to be x plus 1 twice. So what if this would have simplified to be, hold on. What if this would have simplified to be a negative 1? This would have been x minus 1 squared. What if this would have simplified to be negative 2? This would have been x minus 2 squared.
So instead of like going to the simple you can put it straight down.
Yep, you can just go ahead and do it. But once again, let's say you forgot that, you just factor it and it would work out. So that's a fun fact. It's before you squared it that it's factored, but you got to actually square it to add it to both sides. Okay, let's do another example. Write it down. Solve by completing the square. First step is to isolate the variables on one side of the equation. So we'd have x squared plus 6x equals negative 1. We've done our first step. Your second step is to complete the square. We do that by doing b divided by 2 squared. What's my b value? 6 divided by 2 squared. I'm showing my work for a reason, because we can use it. If you do it in your head, you're not going to be able to use the trick. 3 squared is 9. That's the part we have to add to both sides. So you're going to say, I'm going to add 9, I'm going to add 9. So rewrite your problem. X squared plus 6x plus 9 equals 8. Now we could do the old school factoring, what multiplies to be 9 and adds up to be 6, 3 times 3, or we could use our trick. Isn't this positive 3? So it factors to be x plus 3 squared, and that's equal to 8. Now we've written it in a form that we can just simply square root both sides. Pretty easy, right? In Sec 2, this is like, blows people's mind. They're like, whoa, this is so hard. So, and it really, it's funny looking back. So now we have x plus 3 equals plus and minus root 8, which is 2 times 2 times 2. So we actually have this. X plus 3 equals plus and minus 2 root 2. True? So then from there, split it up. X plus 3 equals 2 root 2, and x plus 3 equals negative 2 root 2. So then solve. Subtract 3, subtract 3. So x is equal to, just like a plus bi form, we put the number first. We just put our whole number first on this too. So that would be negative 3 plus 2 root 2. And then subtract 3, so x is equal to negative 3 minus 2 root 2. There's our two solutions. Easy stuff. Okay, now here's one little wrench getting thrown into it. If we have a coefficient that's not a 1, we do have to take care of that first before we can complete the square. So write that down in your notes. We need to be better notes takers. If something's different, you probably should take note of it in your notes. So, to solve by completing the square in the future, we just have to look at that, and without being told no, we got to take care of the 2. We have to have there be a leading coefficient of just 1. So, what we're going to do is the same first step, we're going to get everything with the variable on one side and anything else on the other side. So we'd have 2x squared plus 4x equals negative 3. Now, we can factor out a 2, can't we? Now, we're going to want to factor out no matter what. Whatever this is in front, that's what has to be factored out, period, end of story, no matter what. So we'll pull out a 2, and then divide by 2, divide by 2. So then left would be x squared plus 2x, and that's equal to negative 3. So now to get this side alone, what would we do? Divide by 2. So now we're looking at x squared plus 2x equals negative 3 halves. And now we can complete the square. So now you just continue as normal, as is. B divided by 2 squared. B divided by 2 squared. So that'd be 2 divided by 2 squared. So that's 1 squared, which is 1. So now add 1 to both sides. So now we have x squared plus 2x plus 1 equals negative 3 halves plus 1. Well, we can actually add negative 3 halves plus 1. But to do that, we got to get a common denominator. So which is 2, so 2 over 2. So now we have this, negative 3 halves plus 2 halves. Isn't that negative 1 half? So we have negative 1 half on this side. What would this side factor to be? So this side is x plus 1 squared. So we have x plus 1 squared equals negative 1 half, and now it's not too bad. The hardest part is being able to simplify a stinking radical correctly. So what would be my next step at this point? Square root it, square root it. So then root cancels out with power. So we have x plus 1 equals plus and minus. When we have a fraction and radicals, don't we split up the top from the bottom? Always put the negative on top just for, I don't want a 9 in the denominator because then I have to fix it. We learned that last time. I'm going to put it on top. So I have the square root of negative 1 over the square root of 2. So we have x plus 1 equals plus and minus. What's the square root of negative 1? So we have an I on top and a root 2 on bottom. Is it even appropriate to have a root 2 on bottom? No, so we got to rationalize the denominator. The hard part wasn't completing the square. The hard part was being able to simplify simple radical stuff. So now we'll rationalize our denominator. We multiply by root 2, and now we have an appropriate answer. We have x plus 1 equals plus and minus I root 2 all over 2. So now we can go ahead and split it up. X plus 1 equals I root 2 over 2, and x plus 1 equals negative I root 2 over 2. So then I'll just subtract 1. Subtract 1. This is an a plus bi number, so we got to write the a part first. So that'd be negative 1 plus I root 2 over 2. 2. And x is equal to negative 1 minus I root 2 over 2. There's our two solutions. We can't because that wasn't divided by 2, was it? We leave them separated, yeah. Yeah, yes. We did it to both. We have to do it to both sides, don't we? So now it's gone. Just like solving anything else, if you do it to both sides, you're good, right? Yeah, good question. Okay, let's do, there's one more, I want to do one more, and it's because there's some weird fractions involved in this one, and it always throws people off major. I'm really bummed out. I actually didn't do this example in my early morning, and I know they're going to cry when they get to a problem like this. So we got to go over one. Yeah, you can cry too. Okay, so first of all, solve by completing the square. We isolate the variable. So we would have 2q squared plus 6q. It's actually not any harder, honestly. Equals 1, right? Then we'll factor out our 2. So then would be q squared plus 3q equals 1, right? So now you'd say I got to divide both sides by 2. So we're actually now just looking at q squared plus 3q equals 1/2. And now we're okay to complete the square. b divided by 2. So watch, we're going to have fractions, but that's not going to freak us out. 3 divided by 2 squared. Right?
Yes.
Which is just 3 squared is 9. 2 squared is 4. So we're adding 9/4 to both sides. So now on this side we have this. Q squared plus 3q plus 9/4 is equal to 1/2 plus 9/4. Now this side is going to be hard to factor unless we use our trick. What is the trick? What's it going to factor to be? We added 9/4.
Oh, it's down.
It's this one, right? Yep. Q plus 3/2 squared. The trick doesn't change just because there's a fraction. And then on this side is equal to, we would need a common denominator, so you multiply by 2 over 2. So then we would have, 11/4. 11/4. So now we're all good now. Just solve by taking square roots. So square root, square root. Root cancels out with power. So we have q plus 3/2 is equal to the square root of 11 over the square root of 4. We don't even have to rationalize because the square root of 11 is square root of 11 over 2. And I forgot to write a what? A plus or minus. Very common thing to do. So now we have q plus 3/2 is equal to root 11 over 2. And then we have q plus 3/2 is equal to negative root 11 over 2. And then we literally just have one more step. Subtract 3/2. Subtract 3/2. So q is equal to negative 3/2 plus root 11/2. And then we have q is equal to minus 3/2 minus 3/2. So we have negative 3 over 2 minus root 11 over 2. Now understand something. Your book might write it differently. Aren't they both a common denominator? Can't we write it like that? If they're the same denominator, we can put the numerator together, can't we? So we could write it like this on the test, equally acceptable to this. But I'm just showing you so that when you check your answers in the book, you're not like, well, they have a different answer than I do. Because they don't. They have the same answer as you. Okay, we're done with completing the square. This is wrapping up the end of this lesson here. So Pythagorean Theorem, you'll see why. This is helping us be able to do some real world story problems, but it's Pythagorean Theorem, very easy stuff. So just a reminder of how Pythagorean Theorem works. A squared plus b squared equals c squared, where c is the hypotenuse. That has to be on the right side of the equation. That's why I've underlined it. That side has to be on the outside of the equation. The Pythagorean Theorem only works with right triangles, and it allows us to find missing side lengths. So people get too caught up in A, B, and C. So I just say one of the sides plus the other side squared equals the hypotenuse squared. So let's set up a true statement. Solve for question mark. Ready, go. What's a true statement? So then that would be 9 plus 16 equals question mark squared. So that's 25 equals question mark squared. Do you see why this is in this unit? Because then we're solving. Square root. So question mark is technically plus or minus 5. And in the context of this problem, a negative side length would not make sense. So our answer would just be 5. But we do need to put plus or minus, right, when solving and taking square roots. Just a reminder. Okay, you can't just do 6 squared plus 2 squared equals question mark squared. Not true. What's the true statement on this one? 2 squared plus, or question mark squared plus 2 squared equals 6 squared. So then from there you'd say, so question mark squared plus 4 equals 36. So then question mark squared equals 32. So then we have question mark is equal to the square root of 32. True?
Yeah.
So then we break it down into 8 times 4.
Yeah.
And then 8 breaks down into 2 times 4. So wouldn't that be 4 root 2?
Yes.
So we'd have 4 root 2. Throwing out the negative one. So that allows us to do these last 2 story problems. They're just Pythagorean Theorem, so don't get freaked out too much. So everybody, it says, the hard thing is drawing the picture, but, wow, choking. But the thing is, guys, once you've seen one of them, you set them all up like this. So, sorry. Okay, a lighthouse is 162 feet tall, with an observation deck located at 158 feet above the ground. So a location deck, that's where people stand. Okay. According to the website for the lighthouse, it states that if a person is standing on the observation deck, they can see 18 miles out. Assume that the Earth's radius is 3,960 miles. It says verify their claim. So let's draw a picture here. We have our here's our world, the world, around world, okay? Here is the pop-up of the lighthouse, not drawn to scale, obviously, okay? Now their eyeballs are looking out to the water, right? So which would be down here, it's round-shaped here. They're not going to be looking out here into space. They're looking at the water. And we have our center of our circle here, the center of the Earth, and our radius is 3,960 miles, right, everyone? So no matter where I draw a radius, here, 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 or here, that's also the same length, right? 3,960 miles. Yep, and then add. Now it says from here to the observation deck. That's the important part, right? It said, so this 162 is just kind of extra information. From here to the observation deck is 158 feet. So now, don't I have a right triangle? Yeah. Now notice, one thing to know, everyone, the right angle will always be at the point of observation that they're looking at from afar. So from the radius to the point of observation will always be the 90-degree angle here. Okay, now it says they can see out 18 miles, so this is 18. So there isn't even any unknowns, is there? Yeah, just adding and solving. So let's just pretend it's like, are they right? Can they really see out 18 miles? Let's pretend that's not 18. Let's just see if it works. Let's put a question mark here and solve. So my true statement would be this squared plus this squared equals this squared, right? 3,960 squared plus question mark squared equals. Now notice this one's in miles and this one's in feet. You can't just add them up or else you're saying 158 miles. So, fun fact for you. There's 5,280 feet in 1 mile. So 158, we would, to convert it to 1 mile, to convert it to miles, we would divide it by 5,280. Somebody last hour said they remember it like this. 5 tomatoes. Do you see it? That's funny. 5 to, like a tomato, 5 tomatoes. That's so funny. Okay. So now this side length is actually 3,960 plus 158 over 5 tomatoes.
Do you know what decimals?
Squared. No, we can't do decimals, but that's where we're going to get our decimal, right?
Yeah, I have it.
Awesome. So now we got it. The hard thing is we only have doinky little calculators, and the hard thing is actually being able to calculate it right in our calculator. So let's all practice this. Okay, so sir, you said you got this decimal?
Yes.
What is it?
It's 0.0299.
Like that?
Yeah.
So it's going to be 3960.0299 squared. So then equals, and then we're going to we'll calculate this, right? We have 3,000, so, uh-oh. My pen's wigging out here.
That's 15,681.
15,681 plus question mark squared equals, now calculate that.
Oh, it's million.
It's not, it's, and then he wasn't done speaking, and then I cut him off, so then it was 600, right?
Yeah.
600 plus question mark squared equals, let's do that squared.
We have to know how many that's feet miles. So.
Yeah. But they'll tell you the radius thing. So we just had to know there are 5 tomatoes in 1 mile. So 5,280.
I'm just because like why you're adding 158.
Because that's feet. Like this is miles and some feet. So how many feet are in a mile? This would convert it to a mile.
Miles of the earth.
Yeah.
All the radius.
Yeah. So that squared is this 156,1,836.81. Then subtract that over.
Oh, I don't know.
Did you not get that?
I just
That's coming out. So then I have this. Question mark squared equals 236.8. I'm rounding at this point, so I'm close enough. Yep. This minus this. And then we'd square root that. So the square root of that. Two, 3, 6.8. So that's 15 point, question mark is 15.4 miles. Can they actually see 18 miles out? No. The website was lying. No one cares, but, you know, we'll jump through the hoop that they want us to jump through. No one actually cares about that. I get that. Neither do I. But we have to do story problems, so it is what it is, okay? But it wasn't that bad, right? It was just Pythagorean Theorem. Okay, so watch. I won't go through the whole process of this one, but let's just make sure we can set it up. So it says a person, watch, this is really easy. You'll draw that same picture every time. A person is on a boat. You'll always draw a round world. A person is on a boat that is this high, 220 feet high. So, oh, from the top of the earth, though. Here's the water, right? So from here to here is the top of the boat, and that's 220. I won't even draw a boat. It says, suppose the sailor climbs a main mast that is 200 feet high after that. It says, in order to see enemy vessels, so their eyeballs are looking out to the water somewhere out here, right? Yeah. It says, how far can he see out? So we want to know this. And then it says, assume the radius of the earth is 3,960. So you go like this, draw that over, 3,960. The 90 degrees is always here, like I said last time. And then this from here to here is 3,960, right? So this is in feet right here. So now look, we literally have this triangle. Here's my right triangle. Here's the question mark. This is 3,960. And then this is 3,960 plus 420 divided by 5 tomatoes, right, everyone? 5,280. So now you'll do this squared plus this squared equals this squared. And then it would just be the same thing. Calculate the decimals, go for it. Okay, that's the end of that lesson. So we do have another lesson in a minute, but go practice some story problems and then probably some completing the square ones. Because we all know how to do the other stuff.